problems that talk about average. So we said that an average is the arithmetic mean. So whenever they use the word average, that's what they're going to talk about. And you can find it by taking the total and dividing it by the number of items you have. So I wanted to do a couple problems, show you how they can get, some of them are easier, some of them start to get more complicated just with talking about an average. And we also talked about medians, did some problems with medians and modes last time. I didn't pick any out. If you found some you wanted to see, we can go ahead and do some of those. So let's do one where they're giving you two columns. So this is going to be a quantitative comparison question. And they ask you which is greater, the average of B and C or the value A. So we know to get the average, we're actually going to be trying to add up B and C and dividing it in half. That's what the average means. So if I want the average of B and C, I'm looking at adding B plus C up and dividing it in half. That should give me the average because I have two numbers, B and C. So add them together, divide them in half, and that would be the average. And here's what they gave me. So this is information I have about both of them. So I'm going to have to do some algebra first. First thing I want to do is go ahead and multiply both sides by this denominator. So that if I multiply this by C minus A, and this side by C minus A, it'll cancel over here. I'll have the A minus B on one side and C minus A on the other side. Okay, so far so good. I want to get B and C added together. So I'm going to move the B over here so the B and C are on the same side. So I got the B plus C, that's good, that's what I'm looking for first. And I'm subtracting A, so let's move the A over, we'll add A to both sides. So now I have two of them. And that's as far as I can go with the algebra. But remember, I'm supposed to be finding their average. So when you're looking for your average, I've got to add these two together and divide them in half. So I already have them add them together. So I'm going to have to divide both of these in half to get the average. When I take B plus C and average them together, this gives me their average. That's what the question is asking me about. But when I divide both sides here by the 2, because I do the same thing to both sides, I just get A over here. So when you're trying to compare them, we found the average of B and C, and it's the same thing as A. So these two are actually going to be equal. You pick answer C. So that's one that's kind of combining things that we talked about with an average with some algebra and doing one of those kinds of quantitative comparison questions. So let's look at another one.
Are you in the book?
I'm in a different book. Sorry. I got to try to pull problems from other places because a lot of the ones that we have in the book we go over or you have as homework. So I'm picking some other stuff. All right. I'll see if I can leave that on here. Jordan has taken 5 math tests so far this semester. That's a lot. They have 5 already in one semester. If he gets a 70 on his next test, it will lower his average I got to stay on the right problem. Of his test scores by 4 points. And the question is, what is his average now? And here's our choices. 74, 85, 86, 90, 94. So this is one of the multiple choice kind. Any ideas what you could do? All right, so if you start with this problem and you're reading through and you're reading what it's giving you, one of the things you're going to notice is it says average. So pull out any of those pieces of information that's going to help you. I know how to find my average. My average is the total number divided by how many things there are. I have to add them up. Now, they don't tell me anything about the total. My total I don't really know. So when it's talking about my average for my tests, I can figure out his average right now by looking at the total. And they tell you he has taken so far this semester 5 tests. So if I take all 5 and add them up and divide by 5, that gives me his average right now. And they're asking me a question in the end about his average now. So that's why I'm looking at that. Now there's also what's going to happen when he takes the next test. So they say that if he gets a 70 on his next test, it's going to lower his average by 4 points. So once I look at what could happen after the next test, we're going to have this total of these 5 exams. We don't know what it is. So I'm going to go ahead and give it a variable. Since I don't know what it is, I'm going to call it x. I might need it, I might not, but it's an unknown, so I'm going to replace it with something. I could add the total for those 5 tests plus his next one, which is the 70, and now I've got 6 tests. So my average is that total from before, which I don't know what it is, his new test he takes, and they say if he gets a 70 on his next test, it's going to make his average go down by 4 points. Well, here was his average right now. If this is going to decrease by 4 points, it will give me his new average after his next test. So if I take his average now, they tell me it's going to decrease, it's going to lower his average by 4 points. So his average will go down by 4 points after he takes that new test. Once he has that next test, comparing it to what he has right now, there's that 4-point difference. So all I'm doing is comparing the averages and putting in that extra 4 points. I can simplify a little bit. I can go ahead and make these have a common denominator of 5, so I can multiply the top and bottom by 5. So I could have x minus 20 on top over 5, so that I am writing them all as one simple fraction. And you've got 2 ratios that are equal, so you have a proportion. You can cross multiply. You can multiply 6 times the group x minus 20, and it should equal 5 times that group x plus 70. So go ahead and distribute. 6x minus 120, 5x plus 350. I can combine all my x's together, so I'll subtract 5x from both sides. And I can add the 120 to both sides. So I found out what his total is right now. X stood for that total. That total is 470. And he has 5 tests so far. And they want me to find out what his average is right now. So go ahead and take the 470, divide it by the 5, and that should tell us what his average is currently. And luckily, that ends up being one of our choices. Now, you know he has a higher average. If his score is going to drop when he gets a 70, his average has to be higher than 70 to start with. But all these values are higher than 70. You can do it without doing the algebra, but then you would want to take a look at each of these problems, put it in. If his average is 86 for 5 tests, I can multiply 86 with 5, find out what that total is, add 70 more for his new test, and then see what the average is and see if there's a 4-point difference. Start with C if you're going to do that, and see if you need to pick something lower or something higher. But then you would be calculating that once, twice, at least 3 times to be sure. So there are options. If they've given you numbers, you can plug just the numbers in. Say, okay, well, if his average is 86, then that means 86 times 5 gives me the total. I'm going to add 70 more. Now I've got 6 tests. Is there a 4-point difference? And try it. So you don't have to do it with the algebra. The algebra will give you an exact value, but you can do it by just plugging in some of the values. And you have to determine for yourself which one makes more sense for you and which one's going to be faster and more efficient for you on the test. Any questions? Okay. Well, let's look at another one with average. They can do a lot of different things with averages.
So you're saying they have more of these on the test than they have with the other problems?
Probably because average is more basic, so they will have more of those, maybe more in the easy section, and then they do get complicated and they can have some in the harder sections. They will probably, you'll see that, or you'll see median more than you would see mode or standard deviation or other things. Do you need anything? So let's see. Let's do another one that's doing some columns. See if you can think about this one, figure out which one's going to work. We are going to average X and Y, and we want to compare its average with X, Y, and Y. Which one's going to be bigger, column A or column B? Do you think they're the same, or do you not have enough information? Now, they do give you some stuff above it that you're going to need to use. Think about it for a minute. We'll see what you pick.
I would say B because it's too long. But, I mean, that's just off the top of my head.
But what if the Y's were negative? Would that matter?
Yeah.
So what has to be true with the Y's?
They need to be positive.
Are they positive?
You don't know.
But you do know they're bigger than X. That's exactly the reason. B is going to be bigger. You do have 2 of them. And since Y is the larger number, because Y is going to be larger than X, when you add up the 2 that are larger compared to just one that's larger and one that's smaller, it is going to be bigger. So think about when they give you these things, you have to know, are they positive and negative, or which one's bigger, which one's smaller? That's what makes the difference. So look at that information to get it. Okay. All right, so let's try this one. This is another one that's kind of tricky. I would put this in the hard category. So the problem is that a teacher has given some tests. They were more difficult than she intended them to be. So she's going to adjust the grades. And to decide how to adjust the grades, she is going to deduct only half the number of points that a student missed. So they give you an example. So let's say that you have a student and they end up missing 10 points. And so they get a 90% for the test. Now they're going to deduct only half the points. So if they miss 10 points, only 5 are going to be deducted. So now they're going to get a 95. So you see how it's working. And the question is, before the grades were adjusted, the class average was a particular amount. So before the grades were adjusted, the class average was X. We don't know what it is. But she wants to see how doing this is going to change the average for the class. So the question is, what is going to be the average after the adjustment? And here's the choices. You've got 50 plus x over 2. You've got 1/2 times 100 minus x. You have 100 minus x over 2. 50 plus x divided in half, and x plus 25. Take a minute and see what you think you would come up with. Or if you can eliminate some, and see if you could come up with a guess. So here's where looking at what happens with the answers kind of helps give you a clue by seeing some of the things they're doing, and it gives you a start of how to maybe start thinking about the problem.
Can you eliminate x plus 25?
Why? It doesn't fit to you?
Well, yeah, I mean, the 25 has nothing to do with an average. It wouldn't be half of something, in my view. That's why I would take that into account.
So it's not going to be E. Nope. Because that would be, why are they randomly picking 25 points? Well, they gave you an example, and we can kind of go off the example because it actually has some numbers in it, so that's often helpful. When I'm calculating my average each time, I'm taking the students' scores and adding them all up and dividing by how many I have. One of the homework questions that is for this week, they have you calculate an average, and then they add 5 to every number and calculate the average, and they want you to see how that affects the average. So anytime that you add numbers to all the scores, if you add a certain amount to the scores, the amount you add just gets added onto the average. So my average will increase by however much we end up changing the scores. So I know that my average will get adjusted. It'll move up or move down by this decision of adjusting the scores. It's going to increase. So my average is going to be higher than it is right now. I have to figure out how those scores get adjusted each time. Now they're talking about the points that you miss. So I want to see what the points are that I'm missing. I can have a student's grade. I can take off their score. And that's going to tell me how many points they've missed. And we're only changing our score by half of that. So that total gets divided in half. They're taking half of their missed points. Half of those missed points gets added back in to my average. My average is that unknown value or my unknown score. I don't know what the score is, so whatever that score might be. I'm looking at all those scores together for my average. So this is how many points get added back on to my average. I need to take this amount, the 100 minus my score, and that's how many points I missed. And she divides those points in half, and she gives half of those back to me. So this is the amount that I get added back on my score. I'm going to add that back in to my average. So this stands for your missed points. That get added back on. Half of what you missed, so that's why it's divided by 2, and you can find out how many you missed by taking your score away from 100. That's what gets added back on. So I want to add those missed points back onto my average, because how averages work is they're just adjusted by that different amount, and that's one of the things the homework problem for this week is hopefully showing you. Well, I need a common denominator, so I'm going to need them both to have a denominator of 2 so I can work with them. So I'm going to multiply this by 2 and divide this by 2. So I have 100 minus x plus 2x over 2. I can combine the things I've got on the top. 100 plus that average divided in half. And when I'm checking to see what I have one that's almost close to this. You can think of it as 1/2 of 100 plus x, and I'm looking, I go, oh, I think I have that. But what's wrong? Is it the same? It's minus. And it's not going down. Remember, our average has to increase because we're adding to it. So I'm going to eliminate b. It's subtracting. I can't have subtracting. If that had been a plus, that would have been my answer. So I'm looking at the other ones. And when you multiply this by the 1/2, both the 100 and the x have to be multiplied by 1/2. So 1/2 of the 100 gives me 50. And then only the x is what's divided by half. And so it looks like A is going to match up. I have 100 minus x over 2. So again, you got a minus. So that's another one that could have gotten eliminated. And the 50 plus x over 2 looks good, except that they've already divided the 100 by 50, but they kept it over the 2. So there's just little things that are slightly off. So it gives you some idea of things you might be able to eliminate. I know by adding points on, my average should increase. So some of those ones with the minuses, I'm going to eliminate right away. So I have other things to pick from. So this is one that takes some knowledge about what happens with an average and how adding things or subtracting things to an average affects the average. So it's more of a thinking problem besides just necessarily one that you're working stuff out, not necessarily a plug and chug type of problem. Questions you guys have on this one? I needed a common denominator, and this one had a denominator of 2. So to give this one a denominator of 2, I had to multiply 2 on the bottom and on the top. So that's where the 2's came from. And since they have that same common denominator, I wrote them as one fraction. So here's the 100 minus the x, and then plus the 2x. I just put the 2 in the front instead of at the end.
And then when you went down, you just divided by, you canceled out the 2x.
Right, so I had minus x plus 2x. I combined them, so that just gave me 1x. but it was a plus in the end instead of the minus. Yep. You want to do another one of the averages before we go on to some probability stuff? Okay. All right. So they are talking about an average. So I do have to go back to the idea of what is my average. Average is where you add them all together and you divide by how many you have. So they want you to find the average of x, y, and z. So I know that means I'm going to have x plus y plus z, and there's 3 items, so I'll divide it by 3, and that should give me my average. That's what they're asking me to find. That's what I got to figure out. But the information they give me is kind of in an odd format because they have x's and y's and z's, but each of them are added with something else, and that's where they have the setup. I see them as a B, and a C. It'd be easier if they asked me to add A, B, and C together and see what I got. Because I could average A, B, and C pretty easily. I could take what A is, I could take what B is, I could take what C is, and I could add all those up. But I do notice that in each of these answers, they do have A plus B plus C as part of it. So I'm going to start with that. That's not necessarily what I'm supposed to be averaging. I'm supposed to be averaging X, Y, and Z, but we'll see what we've got when we start. They tell me that A is X plus Y. I'm going to add B to it. B is going to be Y plus Z. And C is going to be X plus Z. So when I add A, B, and C together, it's the same thing as adding X plus Y, Y plus Z, and X plus Z. You can kind of think of them as groups. Here's your A, here's your B, here's your C. So this is what I get when I add A, B, and C together. Well, that's starting out okay, because I noticed that this isn't all my answers, so that's good. But I want to combine what I've got on the other side. I've got 2 X's, I've got 2 Y's, I've got 2 Z's. I could factor that 2 out. And now I've got X plus Y plus Z. That's kind of what I really wanted. I wanted X plus Y plus Z, and here he is. This is good. So far, so good. I'm going to get rid of the 2. I'm going to divide this side by 2 so that they'll cancel. I'll divide this side by 2. Now, here's where you have to be careful. Because at this point, you're going, oh, great, this is one of the answers. I see it over here, A, B, C, it's 2. I could choose that. Or you might think A plus B plus C, and the average, I'm dividing by 3. That one might have been a plausible answer. But both of these are trap answers, okay, because you're not finished with the problem. So don't stop in the middle just because the answer is there. This is X, Y, and Z. X, Y, and Z is equal to A plus B plus C over 2. I don't just want X plus Y plus Z. I have to divide this by 3 to get the average. So if I am dividing this by 3, it's like multiplying with 1/3. It's the same thing. I'm going to have to divide this one by 3. I already have a 2 on the bottom, so I'm going to have 2 times 3, or a 6 on the bottom. So here's my average, and that's what they're asking me for. Here would be the one I'm looking for my solution. It's on there also, but it's D. Because you have 6 values that you're adding together?
Yeah, they are the same value. What do you call it? They're the same, but there are 6.
There are 6. There's 6 items you're adding together, but they're not all the same. As an average, you're averaging those, but there's twice of each one. So that's where part of it's coming from, and normally you're adding those 3. But I mean, there are those types of similarities you can make. So depending on how you're viewing it, yeah, you could think of it like that and do it that way. I mean, I'm not exactly sure what all the connections are you're doing with that, but there are mathematical support for that, what you're saying, with those averages, and that there's 6 numbers. But you have to be careful with that. You can't just say, oh, there's that many numbers, so it's always going to be that divided by. It happened in this case for particular reasons, but not always in every situation. But yeah, for this one, yes. Questions on this one? Now remember, you're going to get a problem and you're going to look at it and you go, I don't like this problem, and you're going to want to go on. But unfortunately for the test, you just have to answer them. My son came home, they took the practice ACT the other day. So he comes home and he goes, I did really great on the ones I did. They have, 40 questions, and all the ones he did, he missed like maybe one problem. And then he goes, and right here, problem 32 to 40, I ran out of time. And all of them, he goes, you have 2 minutes left, and he guessed. He got one of them right. That's right. He got one of those correct. So that did help his score. But the other 8, they were wrong, guessed incorrectly. He didn't even have time to read them. If he had even had time to read through them, there was some that I looked at that he missed. I'm like, if you just read this problem, you could have picked the right answer. But he didn't have enough time left. So timing is a really important thing. As you're going through these problems, read through every question. You don't want to end up having no time left and having not had read all the problems, because what if there was a really easy one at the end? You would have gotten it if you just had time to read it. So make sure that if it looks like it's going to be complicated, you don't know where to start, you go, I really hate this problem, I wish it was not on my test. Mark it and go on. So use that mark and review feature where you mark your answer, go, this one looks like it's going to take me more time, more than my, almost 2 minutes, quasi a little less than 2 minutes for each problem, 1 minute and 40 seconds for each problem. And so I'm going to say, I'll come back to it. I've seen it. I know it looks difficult. I probably could figure it out if I have enough time, but I want to get to all the easy ones first. So since you have that option now, make sure you get through, mark it, and come back to it so that you go through and make sure you don't miss an easy problem that you could have gotten if you just had the time to read it. Because some of these that are a little bit more on the challenging side for the averages. Any other questions you guys have working with averages? We did some with medians in class the other day, so I picked some with averages today to talk about. Well, let's go on and do some stuff with statistics. Statistics we have not done in class yet. So I'm going to give you a little bit of background with the statistics, and then we've got some problems to do for it. For the probability, we want to talk about a couple different things. First, we want to talk about counting methods. For counting methods, what happens is you might have a lot of different choices. So they may ask you, how many ways is this possible? In how many different ways can this happen? So that's what the counting methods are doing, counting the number of possible ways that you have for something to occur. So it says if you have m ways of doing one thing, and you have n ways of doing something else, there are m times n ways of doing both. And what it's telling you is if you have a whole lineup of items, you can calculate how many different options you have. One of the things I want to mention, because this will help to tie some of these ideas together, is they talk about doing both. And when we do some of the probability, we talked about where we did the Venn diagrams, A and B overlapped, you had both things going on. Well, in some of the probability we'll look at, notice these are multiplied together. So both and multiplying kind of are that same idea in this and when we do some probability as well. You've heard those commercials for pizza where they tell you about all the toppings and they tell you how many astronomical different combinations there are for your pizzas. So maybe you're going into the pizza store and they have 3 different kinds of crusts. You can have thin, you could have thick, you could have the stuffed crust. Then they have 8 different toppings that you could pick from. So maybe they have pepperoni, sausage, ham, mushrooms, green peppers, olives, onions. I need one more. Anchovies. Nobody picks that one, but that's okay. So they have 8 toppings. And then they give you the option that you could either have regular cheese or extra cheese. Sometimes when they do the problems, you aren't going to only pick up just on the numbers because they may put in numbers for things and you are automatically drawn to that, but they may have some options where they've listed them out. So if we were doing the same thing for a meal, notice they may list out the 3 desserts they have. There are 3 of them, but they don't put the number 3. They just tell you what they are. Or they may list out the beverages, coffee and juice. There's 2 beverages, but they don't put the number 2 and say 2 beverages. They list them. So be careful with that in these types of problems. I can have more than just 2 items being multiplied together. For this one, for my pizza, they're going to want to know how many different options do they have. Because on their commercial, that's what they want to tell everybody, because it sounds like a really big number. So for their pizzas, I have 3 kinds of crust to choose from, so I might pick any one of those 3 crusts. I have 8 different kinds of toppings, and then they give me the cheese or the extra cheese. So I still have 2 additional options based off the cheese. So I've got the crust and the toppings and the cheese to pick for my pizza. So when they advertise this, how many different ways are they going to say that we have? How many different kinds of pizza are available for you to choose from? There's 48 different ways that you can combine 8 toppings and the different cheeses and the different crusts together. So a problem Now we're going to assume that he needs each item of clothing, and in the problem it actually says if he uses a suit, a shirt, shoes, socks, so he has to have one of everything. So it tells you Dan has 3 different suits, he has 4 different shirts, 2 types of pairs of socks, 5 different pairs of shoes, and then how many ways can he dress himself? So this is one where you're counting the number of ways. So we're going to use that idea of the multiplication principle. So what kinds of things are we going to be multiplying together? When you first look at it, you got some numbers that just stick out. 3, 4, 2. So I've got 3 times 4 times 2. Is that it? Don't forget about these. Again, they may put some of them in words, some of them in numbers, so you've got to make sure you get them all. How many different outfit combinations does he have that he can actually choose from? Although they may not all look good together. 120. So that would be the choice. This was the fill in the blank, so you had to actually put in a number and find out how many you had. So they were leaving it up to you, and you didn't have choices to choose from. But that's how the counting methods goes. Now there's a couple other types of counting methods we want to look at. One is working with permutations, and one's working with combinations. Have you heard of permutations and combinations before? Sound familiar? No? So let me see if I have a definition for you. I want to give you a formula for permutation, and then we're also going to talk about it using some blanks. But this is the actual definition that you have for permutation. We want to look at how many different ways we can arrange things, so it's kind of like that counting method, but it's arrangement of so many objects out of a total number of n possible objects, and here is your key. Order is important, because the difference between permutations and combinations are going to be whether the order is important or not. Doesn't matter. And the formula that you have for a permutation, and on some of the other calculators, not the ones you guys get to use for the GRE, but you may have seen this notation before in the statistical setup where you have n items and you're going to pick so many of them. So we'll give you an example. The formula that we have is going to use the idea of factorials. They want to look at how many items you have total. And then we're going to divide it by n minus the number of items we're picking as a factorial. So I'll show you what that looks like for our example. We have a total of 8 items, and we need to pick 3. So this problem might have been one where you had 8 runners, cross country, we were there, 8 runners, cross country, and they are going to count the first 3. You've got gold, silver, bronze. Order is important to those people. They want to come in first, or they come in second, they come in third, but their placement is important. So first, second, and third place, those are the ones that are going to get the medals. It's important. They're going to say if it's first or second or third place. My order is important. So I want to see how many different possible combinations there are for who could come in first, who could come in second, and who could come in third out of those 8 runners. So we have 8 factorial on the top, and then we have 8 minus 3, or 5 factorial on the bottom. Now, do you know what a factorial does, what it looks like for a factorial? No idea? With a factorial, all you're doing is multiplying that number from itself all the way down to 1. So 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And if you had big numbers, they could get pretty long. The nice thing is I'm going to be able to cancel it out with some of these guys, because a 5 factorial is 5 times 4 times 3 times 2 times 1. So I notice that I have a lot that are going to end up canceling each other out. All of these. All I'm left with is 8 times 7 times 6. There were 3 places that we were concerned about. We had 8 runners and we wanted to pick the 3 places. And that's what we have, 3 items left for those places. And what is 8 times 7 times 6? How many different ways could this happen? 336? Now another option that you can use if you don't remember the formula is you can set them up. But I will say that I did notice on some problems that they have as sample problems, and we'll do one, they were more in this kind of format. So that's why I want to show you that in case your multiple choice selections are looking like that, so you can identify which ones they might be. But for this, I could use the idea of blanks. I'm going to be multiplying three things together. And somebody's going to come in first place, somebody's going to come in second place, and somebody's going to come in third place. And I want to look at how many options I have for each one. So when you're talking about your runners, we had 8 runners, 8 kids all together. There's 8 kids that might show up and come in first place. So I have the possibility that any of those 8 kids might be in first. But after you've picked first place, one of the kids is gone. So you only have 7 kids remaining to take second place. So for second place, it's going to be one of the remaining 7 students. And for third place, after first and second place are taken, you've got only 6 students left that might come in third place. So you can use the idea of the blanks, 8 times 7 times 6. It'll give you the same thing as the formula. And our answer turns out to be exactly alike. There's 336 different ways I can combine it so that when order is important, I can have the top 3 first, second, and third place out of 8 runners. Now sometimes the idea of using these blanks is a lot easier. And if you have repetitions, it works a lot better for repetitions to use the blanks. So I would recommend when you're doing these, probably setting them up with the blanks is the best way to go. I do want you to see the formula so you have an idea of what it is, and so you've seen these, because if that's on your multiple choice answers, you want to be aware of where it came from and what they're doing and not just freak out. Now I want to compare that to a combination, because the difference with a combination is the same idea, but we're doing it as a group. And so for a combination, the order is not important. So when you read through these 2 different definitions for what they are, we are again looking at an arrangement. How many ways can we arrange our possible objects out of a total of n possible objects? So it starts out looking exactly like a permutation. Here's the only difference. Order is not important. Not. So you have to make that decision. Is order important or not? So let's do the same type of idea in a different kind of example. Again, if you want to see what the formula looks like, we have n items, and we're doing a combination, so you'll see a big C for combination. I have n choose r items, and I want to find out how many ways I can do that. It starts out with the top, still using those factorials. You have the n minus r factorial, just like before. You have one new item that's different. This is the only thing that's different between them, is that you now have an r factorial on the bottom that you didn't have before. That's going to end up dividing your number, so you're not going to have as many options because you'll be dividing it by another value. So let's do the same thing. Let's say we have 8 people, and we're trying to build a committee. So 8 people showed up to the board meeting, and we need a committee of 3 people to take a look at this area. Whatever the issue is, we just need 3 people to be on the committee and work together. But once they're on the committee, everybody on the committee is on equal footing. It's not like one person's more important than another. So the order that I choose those 3 people isn't important. I just need a group of 3. This group of 3 people are going to be on this committee. So since the order isn't important, I'm going to start off just like I did with the permutation. I've got 8 minus 3 or 5 factorial on the bottom. But here's the new part. I now am also going to have a 3 factorial down there because that's my value for r. So when we multiply 8 factorial and the 5 factorial, those are all going to cancel out, but I also have a 3 factorial that's different. 3 times 2 times 1 that I didn't have before. All the rest of these cancel, just like they did previously. But now notice you have that 8 times 7 times 6, and you're dividing it by 3 times 2 times 1. Well, 3 times 2 is 6, so I can eliminate the 6 from both. All I have left is 8 times 7, or 56. Notice it is smaller than what we got before. Because the order doesn't matter for those 3. I just need a group of 3. So it doesn't matter if I say Bob, Sally, and Jim, or Sally, Bob, and Jim, or Jim, Bob, and Sally. Those count as separate things when order matters, who came first. But in our group, that's the same group of people. So it doesn't. So that's why you're going to have a smaller number when you do combinations than when you have permutations.
I lost where you got the 3 times 2 times 1. I know that's really elementary.
Because that's the new part to our formula.
All right.
Just the thing that we did before, but now however many items you're picking, you have to divide by that factorial. So when we do it with those blanks, we can still do the idea with a combination of the blanks. I have those blanks all multiplied together, just like we did before. How many choices are for your first person? Well, I have 8 people. I can pick 1 for the committee. Then I have 7 people. I can pick one of those for the committee. Now I have 6 people left. I'll pick one of those for the committee. So I've chosen my 3 people for the committee, but there are how many ways you can pick 3 people. The order didn't matter. So what we're doing is, because we chose 3 people, on the bottom, I'm going to have 3 factorial. That 3 factorial stands for those 3 people and how many ways those 3 people can be picked. Because I don't care that Bob was first or Sally was first or Jim was first. It didn't matter. So I would still get that same idea, that 336, divided by 3 factorial, 3 times 2 times 1. And take 336 and divide it by 6 and tell me, do we get 56? Because we should. So you can use this idea of those blanks just like we did before. The only difference is if you have a problem where the order doesn't matter, it's just a group that you want, you have to divide by that factorial for how many items you have in the group. I need 3 people on my committee, so I'll divide by 3 factorial. If you were choosing 5 items, then you divide by 5 factorial. So whatever it is, how many items or how many blanks you have, that's what you'll put down at the bottom for your factorial. Any questions so far? Now the idea of using the blanks, this works if you have a particular type of problem, but the blank idea is going to be helpful for all kinds of problems. So let's do some examples with some where we'll set it up with the blank and we'll use the idea of filling it in so you can see how to do those. Is this the 10-digit number? 1 or not? They are asking you about a 4-digit number. So I have 4 different digits. I have a first digit, second digit, third digit, fourth digit, and they want to know how many of those are going to have only even digits. Go ahead and see if you can calculate and come up with a value that you think is going to work from your multiple choice, and then we'll talk about it. Any takers for A, B, C, D, or E? No idea. Do you have a guess? No guess? No guesses? You even guess it? See, I told you could guess wrong. My son guessed all of the last ones wrong. That's okay. Guess. Just so we guess. You think it's B or D? B. You want to take a guess? No idea. Okay. We want to think of what our options are for each of these digits. So they want them to have only even numbers in them. So I want to make a list of my even numbers. What are your even numbers that you might have that could fill in for these 4 different digits? 2? Is that it? Well, those are even, 2, 4, 6, and 8. So we got 4 numbers. So I have 4 possibilities for my first digit. There are 4 choices for that first one. Now, what are your possibilities for the second number? Are they the same? What are your options that might go in here? They have to be even. My even digits, 2, 4, 6, and 8. But you also could put in 0. 0 is something that would be considered even. So my options for this would be 0, 2, 4, 6, and 8. Any one of these numbers might be my second choice. 0 would be, if it ends in 0, it's divisible by 2. Anything that ends in 0, it's divisible by 10. It's considered even. You can divide it in half. So if you have a 4-digit number and there is a 0 in it, it is an even value because it's divisible by 2. So I could have any of these 5 different values for it. Now, how come you couldn't have had 0 at the beginning? Why does 0 not work for the first one?
Because it has to end in 0 and be divisible.
It doesn't have to end in it. You could have a 0 in any place, but what if you had a 0 at the beginning?
Then it's not a place.
Then it's not a place. So you wouldn't have 4 digits. You have to have a 4-digit number. So I can't start with a 0 because then I'd only have a 3-digit number. But I could have 0 in any of the rest of these. Would you tell me that this isn't an even number? It's a 4-digit number. Is it even? Yes? No? Yeah, it's even. It's divisible by 2. So it's considered even. So I can have zeros in my value. I just can't start with a 0. So I have 5 possibilities for my even digits here and 5 possibilities for my even digits here. So you're looking at how many options do you have. For the first number, I only have 4 options. Has to start with a 2, a 4, a 6, or an 8 to be even. 0 isn't going to work because then I wouldn't have a 4-digit number. But I have 5 options for these other places. So if I multiply 4 times 5 times 5 times 5, which choice does it look like we should go for? 500. More than you thought. So you can use the idea of the blanks to answer some of these types of questions as well.
So it's because 0, 2, 4, 6, 8, we put 5, 5, 5?
Right, because there are 5 numbers, because you're looking at how many ways are possible, and there were 5 options. So you're putting in how many options you have for each of those places. Yep. So I have 5 choices. I could choose from 5 different things. This next one's similar. It says how many 10-digit numbers are possible using only the digits 2 and 5. So you've got some restrictions. This time we need a 10-digit number. So I'm going to have 10 blanks. That's my 10-digit number. It's pretty huge. But I want to look at how many options I have for each of these values. What are your choices? How many choices do you have for that first digit? 2 choices. It can either be a 2 or it can be a 5. That's it. 2 choices. 2 or 5. How about for your next one? How many choices do you have? 2 again. 2 or 5. What about this one? What are your 5 choices? I could put the number 5 there. That would be true. What else? Each time, your only choices are 2 or 5 because those are the only things you can use. I can put 2 or 5 in here every single time. I have 2 choices, either a 2 or a 5 for the first one, either a 2 or a 5 for the second one. 2 choices, a 2 or a 5 for the third one. 2 choices, a 2 or a 5 for the fourth one. Guess what happens? For each of these 10 digits, you only have 2 options every time. A 2 or a 5. So there's 2 options for this, 2 options for this, 2 options for this. So if I'm going to multiply all of my options together, I have 2 multiplied with itself how many times? To the 10th. The idea of using the blanks works well if you have repeated values. This is a repeated value because I could only use a 2 or a 5. So I had the same thing over and over again. So the blanks will work for those repeated values. Do you have any questions of working with some of these?
I do not understand it whatsoever.
Let's see.
I think you turn the question into the equation is the issue.
Right.
That's not what you're asking.
Let's do area codes. We're going to be talking about area codes for phone numbers. How many 3-digit area codes are possible? So we'll look at 2 questions with area codes because this will keep our numbers small. You could do the same idea if you're talking about maybe license plates, what your options are for license plates. So I'm going to use the blank idea, and I want to look at area codes for phone numbers. I'm looking for a 3-digit area code, and I want to find out how many are possible. So I'm going to have 3 digits. Here's my 3 blanks. Now you need to tell me, is the order important for these 3 digits? Yes? No? What do you think? So it doesn't matter if I call 612 or 216, I get the same person? Is the order important?
I guess, yes.
Yes, definitely, because otherwise you will not be calling the right person. So the area code, the order is important, whether you dial 216 or 612, it makes a difference. If you get those numbers switched, you're not going to get the same person. So those could all be different area codes. So order is important. So that's one of the first things you want to figure out. My order is important. So I'm just going to use these 3 blanks to represent my options. How many numbers are possible for you to use in this first blank? We're answering this first question. How many 3-digit area codes are possible? What are your options? What numbers could you use?
You could use all the numbers except for 8.
Well, not for the first question, just the first question. How many are possible, just in general?
9.
We have 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 values. So there's 9 options. And you could list them if you want to. How many options do you have for the second number? 9 again? 10. Why?
Because you can use 0.
You can use 0 now. So I got 10 options for this second one. So I could have 0, 1, 2, up to 9. What about your last digit? How many options do you have for that last number? 10 again. So those are the options. There are 9 choices for the first number, 10 for the second, 10 for the third. So when I multiply them all together, how many different ways can I come up with area codes? How many different area codes are there? 900 area codes. Now, we do not have 900 area codes. They add new ones all the time. They're going to split up Ohio again. They're getting rid of 740 and taking part of 740 to be 740, and the other half is going to be somewhere else because they're going to run out by next March. Did you know that? Yeah. So they may...
But they still keep giving them out.
Right. They'll give them out until they decide what they're going to do and where they're breaking it. They haven't decided where the break comes for 740, but it's coming again. So 740 is getting too big. They won't have enough numbers remaining to give out in that area code, so they're going to have to make a new area code for that. Now, the second part of this question, though, goes, how many are possible if 8 is not in the first digit? So if I eliminate 8, because they're saving those, they might want to use them for toll-free numbers or toll numbers, or, 1-800 is a free, now 866s are free. They're keeping those 8s kind of special. So if I eliminate 8s, and I want to look at this again, and I now no longer have 8s, I only have the numbers 1, 2, 3, 4, 5, 6, 7, and 9. There are 8 choices here because I've eliminated one of those choices. I still have 10 choices here and 10 choices here, but now I only have 800 area codes that are options for working with this. What if we pick something where the order wasn't important? Now, for area codes or your license plate, yeah, it's important that you get it in the right order. But what if we were choosing something where we had these options and the order did not matter? You were putting them all together in some big pot. The order didn't matter. How would it change this if the order didn't matter?
You still have the thing about 8 not being the first digit?
Sure.
Okay.
Yeah.
What do you do?
When order's not important, it does change it.
Oh, you have to do that.
Yes, you got to do that dividing. So if order was not important, whatever you had for your 3 blanks, whether it was the 9, 10, 10 or the 8, 10, 10, it doesn't matter, whichever one we're talking about, I would also have to divide it by what? How many blanks did we have? 3 blanks, so we'll use 3 for the factorial on the bottom. 3 times 2 times 1. So I'd have 800 divided by 6. So the big things to keep in mind are how many options you have for each of these when you're filling in the blank. How many choices are possible? I have this many choices, I have this many choices. And then whether order is important or not, whether you have to divide by something or not. Let's talk really quickly about some probability. probability is usually going to be a value between 0 and 1. It tells you how likely or what the chances are of an item occurring. So typically when you have these, they're going to be given to you either as a fraction or sometimes as a percentage or a decimal. So for example, I'm going to roll a dice, and I am looking for the probability of rolling a 3. So they'll typically set it up where it looks like this, P for probability, and then the item they want to occur is in the middle. I'm wanting to get a 3 when I roll the dice. And for your probability, you're going to be looking at how many times that item will occur out of the total number of possible times. So to get a 3 on the dice, there's only one 3 on the dice when I roll it. So it only occurs once. But how many possibilities are there when you roll the dice? How many numbers do you got on your dice? Normal dice. 6. So you have a 1 in 6 chance, or the likelihood is that you will get a 3 1/6 of the time. And they might write it as a percent, or a decimal, or a fraction. Often they're going to be set up as fractions because it gives you information in this setup of what your probability is. I can use the ideas of probability when I'm talking about the weather. What's the chance of rain? They always give it to you as a percentage, 30% chance of rain. So that means if you wanted to set it up as a fraction, you could, 30 out of 100 times it's going to rain when they're giving you that as your percentage. There are different things that happen if you replace items or you don't. So I want to give you an example where we're going to have a jar full of marbles. And it has one of each color. We got red, white, blue, green, and yellow. And the question is, what is the probability of choosing a yellow marble? Then, if 4 marbles are removed, what is the probability that none of them are yellow? So let's see what you come up with. And then we're going to say what is the probability it is yellow. So they'll change your questions around several different ways. Now we have how many different colors in the jar? 5 colors. And yellow is one of our colors. So the first question is, what is the probability that you choose a yellow marble? There's 1 yellow marble in there out of 5 marbles altogether. So you have a 1 in 5 chance of picking that yellow marble. Usually it would write it as P yellow.
Oh, just the blue.
The probability of picking the yellow marble. We have a 1 in 5 chance. One of the things that you can use is the idea of the opposite. So if you don't want something to happen, you have 100% for the whole sample space. And if I look at it not occurring, that would be 100% or 1 minus the probability it does occur. So one of the options that you have is to not get a yellow one is 1 minus its opposite, the probability that it is yellow. And I can use that for my last question. I want to find out what the probability is that I do not get a yellow marble, that when I take it out, there's no yellow marbles that's been taken out. So the probability that it's not yellow, well, I had a 1 in 5 chance that it was, so I'm looking for its opposite. So the opposite idea would be that it is yellow, and that would be 1 minus the 1/5. 1 being 100%, and 1/5 or 20% of the time it is yellow. So how often is it not yellow? 80% of the time, or 4/5. And here's one where you need to look at the options, because if they give it to you as fractions, you'll want to do your work with fractions. If they give it to you as percents, you'll want to do your work with percents. So you can do it either way for these problems. So that would give me the option of what if I choose all those things and it's not yellow. Let me give you one last problem, working with some of these. And we'll do some more of the probability when we go to class. We've got a bag that's containing chips. It has 6 red chips that are numbered 1 to 6. And it has 6 blue chips that are also going to be numbered 1 to 6. And they're asking you if 2 chips are chosen, and they're going to tell you that they're going to do it without putting any of them back. So it's without replacement. They want to know what's the probability of picking a red chip and then picking a blue chip with the same number. Now we're picking 2 different things, so I'm going to put down 2 blanks because I'm taking 2 chips. And I want to figure out how many ways I have of choosing these 2 things. They're asking you about a probability, so that means I'm going to need a number between 0 and 1. I'm working with those fractions again. So I want to look at how many times the item would occur out of the total, and that's what I want to put in these 2 blanks, are my 2 different probabilities. The first one is I want to look at the probability of taking a red chip. So I want to find the probability that the first chip I pick is red. So how many red chips are in the bag? And how many chips are in the bag altogether? So we got a 6 out of 12 choice of getting one that's red. That's its probability. 50-50. Half of them are red, half of them are blue. The second option is a little bit more complicated. They want you to pick a blue chip, and it has to have the same number as the red one I picked. Well, how many blue chips are going to have the exact same number as the one that I chose over here? I picked a red chip, and maybe it said 4. How many other blue chips have the number 4 on them? just one. Or I could have picked a 2, but there's still only one blue chip with a 2. Maybe I picked the 6, but there's still only one blue chip with the 6. So there's only one chip that matches and has the exact same number. How many chips are still in the bag? Yes. So here's where I'm picking a blue chip with the same number. And I can multiply these. Again, you don't have to reduce it, or you can. 6 will go into 12 and you'll have 1/2. So you could reduce it. But those are the answers that you're going to be looking for, depending on whether they've reduced them or not on the answer choices that you have, unless it's a fill in the blank. So it gives you some idea of working with some of the probabilities. You can use the idea of the blanks. If it's a probability, you're going to need a fraction here, or a decimal, or a percent. So those are the ideas that you're working with. Look at how many options you have for each. And usually we'll be using that multiplication idea for those counting methods like we did at the beginning. We're going to do some more probability things in class on Thursday. Do you guys have any other questions you wanted to ask today before we finish? Okay, so we'll use the same idea. The question was, what's the probability of getting a face card out of a deck of cards? All right. So when we set it up, we want to look at how many face cards we have and how many cards we have in the deck. Now there's different items that you can do with the cards. They may ask you to find the probability that you might draw the number 3 out of the deck of cards, or the probability that you would get a jack. Or they could do it by suits. They might ask you the probability of getting a heart. So all those things are going to be the same idea as getting the face card. When you're working with cards, you have 4 different suits. You've got hearts, diamonds, spades, and clubs. And you're going to have from ace, which you can think of as a 1, but it doesn't have the face on it, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you start getting into the face cards. You've got jacks, queens, and kings. So I have a 3 in every suit. So the chance that I get a 3, there are 4 3s. There's going to be a 3 of hearts, and a 3 of diamonds, and a 3 of spades, and a 3 of clubs. There's 4 of them, and there's 52 cards. Same idea for a jack. That's a single type of card. So you could have a jack of hearts, or the jack of spades, or the jack of diamonds, or jack of clubs. So there's 4 jacks and 52 cards. When you talk about suits, it gets a little different, because how many suits do we have? 4 suits, and one of those suits is hearts. So you could think of it in terms of suits and say I have one suit that's hearts, and there's 4 different suits. Or you could do it by the number of cards. We've got 52 cards all together. How many of those cards are going to be hearts? Well, the ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. How many do you have that are in each suit? $13 cards. And if I reduce 13 by 52, I'd get the 1/4. So it's the same idea. Now for the one about face cards, we can have face cards out of every suit. So it's going to be similar to what we did here when we talked about the suits. How many face cards do you have that are going to be diamonds? 3. Jack, queen, and king. Ace isn't usually face cards. So jack, queens, and kings. 3 for diamonds. And then I got 3 more for hearts. Jack, queen, and king. And 3 more for spades. And 3 more for clubs. So how many do we have that are face cards altogether? 12. 3 from each different suit. And there were 4 suits. And we got 52 cards. And you could reduce it if you wanted to, or think about it differently. I have 3 out of the 13 cards every time in each suit that's a face card, so it's the same idea. So you could do it by suits as well. So if I divided this by 4, and if I divided 52 by 4, 3 face cards out of each set of 13 that make up a suit are going to be in there. 3 of them are face cards out of all of them. So it's that same idea. Sometimes they'll ask you about doing the probability of getting a diamond or a jack, something like that. And here's where you can have overlap. When we talked about those pictures the other day, is it possible that you can have a group that represents the diamonds and a group that represents the jacks, and there's overlap? Or are they separate circles?
They're separate.
So jacks are totally separate from diamonds? What about the jack of diamonds? He kind of fits in that category, right? So you do have somebody in here. There is one card here, the jack of diamonds, that fits in this area. So when I'm working with something like this, I could look at the probability I might get a diamond, plus the probability that I might get a jack. But like we talked about with those Venn diagrams, if there's overlap, you've counted it twice. So I have to take off the probability that both things occur, that jack of diamonds. And that's the same idea we looked at with the Venn diagrams. So I have 13 cards out of 52 that are diamonds, and I have 4 cards out of 52 that are jacks. But I counted that jack of diamond twice. I counted him once in here, and I counted him once in here. So there's 1 jack of diamonds in that deck, and I got to take him off because I counted him twice. So they'll use that same idea that we talked about with the overlap in the Venn diagrams when they're doing some of these things for probability. One key for working with probability is if you see the probability and you're working with the word or, you're going to add. And that's what we had here. We had the word or. We had diamonds or jacks. So we had diamonds plus jacks. So it's adding and subtracting that goes on. If you see the word and, that means you're going to multiply. And most of the things that we did for counting methods was and. I want to get a red chip and a blue chip with the same number. So I multiplied those together. So a lot of the stuff we did together today was with the multiplying where you were doing the ands and we multiplied stuff. So those are a couple key helps for working with those. But that would be your, either one of these, be your answer for a face card. Does that help?
Because I saw how it has been solved, but I did not understand the steps.
So probability is looking at how many options you have out of the total number of options. So that's how you'd set up your probabilities. So I'm looking at how many face cards I have in the deck of cards, and there's 52 cards in the deck. So that's always how you'll want to set up your probabilities for those. Lisa, do you have any other questions? Nope. Did I just confuse you more today than help?
No.
Okay. She's going, yes, but I am not admitting that. Did you have any other questions you wanted to ask? No? Okay. We're going to do more probability stuff and some more permutations and combinations in class on Thursday. So hopefully that'll help with the last section, and try to do some of the homework before then because it might help. Make it a little easier. All right. Well, thank you for coming.